Well, it turns out all of these are sort of right. um, you really do need to give the answer, but this isn't quite right. You can't guess the answer. If you have an algorithm that just guesses the answers, that algorithm is going to be wrong some of the time. And we're not talking about the complexity of algorithms that are allowed to be wrong. We're talking about the complexity of algorithms that have to be right. So what about this tournament argument? Well, in a parallel computing scenario, you actually can do something like this, where you have the list of numbers that you're trying to compute the max of. You can separate this into two lists. Ask some group of processors to compute the answer for this half of the list and some other processor or group of processors to compute the answer for this half of the list, and then you only have to do one comparison to find the max. The number of rounds that this takes actually really is log n. So this problem is solvable in log n time, but not under the computation model we've been talking about. It's a computation model where there's kind of an infinite number of processors that can share information between them. This big theta of n argument is actually correct. And just to kind of spell it out for you, imagine we've got an algorithm that runs faster than big theta of n. So that means it can't possibly look at every element in the list. So whatever that algorithm has done, let's say it's looked at a couple different elements of the list and it has a guess as to what the max is. We can make sure that this is always wrong by hiding a value in one of the spots in the list that the algorithm didn't check in. And if that number is bigger than everybody else, it can't have answered the question correctly without looking at it. So that's really cool, actually, because finding the max of a list, we have an upper bound of theta of n, and we have a lower bound of theta of n, and they match each other. Another algorithm that you could get a matching upper and lower bound without too much work is for sorting, at least under the model where we're counting the number of comparisons of elements you have to do. And it turns out that, in fact, sorting under a comparison model has matching upper and lower bounds of n log n. So this n log n that we've been having for sorting is essentially the best you can do.